to be able to also make some easy and cheap measurement methods to do it afterwards, but it all starts in the laboratory.
Yes, I have one more thing. The precipitation, the Schrecker precipitation, it's just don't know anything about chemistry at all, but when I hear the words that are linked to that reaction, it's about volatiles, it's about sort of very fine aromas, and then I get interested, you know, how do I make sure that I do not destroy again what I create in this fine reaction, which is a secondary reaction to the MER. Would you have any, I mean, just from top of your mind, what kind of things could cause that I actually, because what happens sometimes is you've got something and then you continue to roast and then you destroy it again, so yeah.
But that's true. I mean, if you look at the MER reaction, normally they say it's like 3 phases in the MER reaction. The first phase is where you just have the formation of the Amadori component. Then you have the second phase where you have the different rearrangements, breakdown of the sugar, the Strecker decoration that feeds into that. And then the last phase, the third phase, is the formation of the dark brown components, the middle lines. And that part is tricky because it's not only well, it is the color components, but at the same time it's also, in that part of the reaction, you get a lot of polymerization reactions. And the polymerization reaction, that's actually recombining again many of the sugar breakdown products. And that gives these colored pigments also when they bind to the nitrogen in the MER reaction. And also in the pure breakdown of the sugar, they also get polymers formed. They have not a brown color, but they also, you can say, take away some of the important flavors that are formed. So you're very right that roasting you should not take it too extreme, because it will take several of the flavor components again into this big polymerization reaction that's happening at the end.
Yeah.
But I cannot advise you like, oh, this is this and this is what you do, and then you have the perfect coffee. I mean, it will depend on so many things. So, but yes, you're right.
If you were to look at it under a microscope, could you actually see these chains and links being formed? Say if you roasted the coffee to a particular level and then ground it and then looked at it under a microscope, are there tangible ways of being able to improve what you're doing by looking at it at a molecular level?
Yeah, I mean, a coffee bean is a heterogeneous system. I mean, when you show these slides of the reactions, then that's always of very, in a way, a bit abstract way. It's not really necessarily what is exactly in the bean, because the bean in itself is also, yeah, you can say it's built in different layers, and there's air pockets, and when you talk about the fats in the beans, they are located in several parts of the beans as small droplets, and it's a very heterogeneous system in a way. And so that's also why it's sometimes difficult, I think, to control the whole roasting, because it will depend a bit on how the structure is within the bean as well. And indeed, yes, you can look in the microscope, and there's studies that use the electron microscope also just to look really at the structure of the beans and trying to see, okay, how is this built up and how does it change after roasting. But they are a little bit, I'm not sure if you just with a normal microscope, if that already gives you some information as well. Probably does. You can also get something there. But I think with all these kind of things, I think you're trying to find easy tools or simple tools to access some information. And I think what one could do is to say, okay, in some of these student projects that you want to discuss also in the afternoon, is maybe say, okay, let's define some of the interesting parameters, and then some of the interesting measurements. And in fact, what you can then do is just to do all these measurements, and then for different kind of roastings, and then collect that data. And then you actually, in multivariate analysis, you probably can find out which of the simple measurements can give some kind of a prediction for a particular flavor that is developing. And that is still a pathway, I think, also with some of the proposals that you have out at the department. I think that could be done. And then it would give you an answer on your question, like, is a pH measurement similar? Can we do something on the microscope by counting pockets or whatever? Yes, and so that will give you some more idea of which kind of methods could be, which tools, simple tools could be used in practice.
All right, I think we've got to think about our next break, but just have time for one more question, if any. Right. So, yes, we're walking in unknown territory, I think, all of us. So, all this, we're looking forward to work forward on this project. Also, we've got links to University in California to continue this research, which probably give you a little bit of impression of what we're trying to achieve. Okay, thank you very much. Thank you, Dr. Brady. Thank you. Morten, is it a short break and then we've got the copying?
Yes.
Yeah. So we'll all meet at 11 at the factory, is it?
Yes.
Yeah.
No, sorry.
It's here.
So at 11, we'll meet here again for a lecture that will prepare you for the copying that we are doing 11:45. And how many of you did not sign up for the copying electronically? Please do that during the break. And if you have some technical questions, please go and ask us, because it's important that you get the link before the copying so that you can just press it and then we can start the copying. Okay? Thank you. Not yet.
For the Wi-Fi, it's on the blackboard. Just it's a whole bunch of numbers.
Ja, det er meget, nogle mennesker synes, det er fantastisk, andre synes, det er en leg. That sounds like a lecture.